Beep. Okay, so we're doing really lesson 15 and lesson 16. You'll do a lot of group work together on lesson 16. So I'm only teaching you lesson 15 because it's the same thing. We're talking about the word and or, okay? So and or are very, very different. Right now I am in math class and English class. So let's pretend that this is a normal classroom. You're sitting in my math class. So are you in math class and English class? Well, that would absolutely be false. You can't be in both classes at the same time. So and means both have to be happening, whereas or, right now I am in math class or English class, that is absolutely true. Why? Because you're in math class. If you were watching this video and you're sitting in English class, okay, well you're not in math class, you're in English class. Again, and both have to happen, or only one has to happen. So, let's take a look at some of these examples and use math now to just kind of determine. So 3 plus 5 equals 8. That's true. And 5 is less than 7 minus 1. Well, this is 6. Is 5 less than 6? Absolutely. That's true because of the and. Both of those are true. 10 plus 2 does not equal 12. Well, that's a no. 8 minus 3 is 5. 5 is greater than 0. So one of those is true. In this case, because it's and, this is absolutely false. Because 12 has to equal 12. Like that, it just doesn't make sense. Okay? So that's how we're doing this together. And both have to be true, or only one has to be true. So solve each system of equations or inequalities. So x plus 8 equals 3, or x minus 6 equals 2. For a lot of these, for the or questions, we're going to have two answers. For the and questions, we're only going to have one. So I'm going to solve each individual equation by itself. So I subtract 8. That leaves me x equals negative 5. There's one answer. Or add 6, x equals 8. There's my other answer. Well, how am I going to show this? Because I don't want to write x equals negative 5 or x equals 8 every time. Well, I'm going to show this in that set notation. For equations, I'm going to put negative 5, 8. Those are the answers that would work. One of those two answers is going to work for one of those two equations. Same thing here. We've got another or. So, add 9. That leaves me 4x equals 9. I divide by 4. X equals 9/4. Or, subtract 5. 3x equals negative 3. Divide by 3. X equals negative 1. So, here's my answers. Well, how do I show this? I'll always put my smaller number first. In this case, it's a negative 1, positive 9/4. Okay? And this is what we're doing. What about the and question? So the answer for this one has to work for this one because the answer has to be for both. That's what and means. So I add 6. I get x equals 7. If I don't get x equals 7, this is not going to work. Subtract 2, x equals 7. Okay, so when it's an and, we know that in that notation, it's just going to be the 7. Well, how about over here? So now this says w has to be greater than 9, and we add 8. This is 2w equals 18, divide by 2. W has to equal 9. Well, can we have something that's w is greater than 9 and w equaling 9? So no. So to show this in a null set, you put that 0 with the scratch through it. That means there is nothing that will work for this number. Okay? Nothing that we can possibly think of for w will work for both equations. And that's important. And means both things have to be working. Well, what about for inequalities? So, let's read these directions. Using a colored pencil, and I would absolutely get some colored pencils, so if you need to pause me, get some colored pencils right now. Or markers or crayons or whatever. Using a colored pencil, graph the inequality x is less than 3. So here's 3, and I'm going to graph that. Okay. Using a different colored pencil, graph the inequality x is greater than negative 1. Okay. Using a third colored pencil, darken the section of the number line where x is less than 3 and x is greater than 1. Well, it's going to be from, oh man, this one doesn't work. That's too bad. Go in the trash can. I just threw it in a window. That was bad too. But all of this position from here to here is my answer. Why? Because it has to work for both. That's where those graphs of the inequalities overlap. So how would I say this? I'd say x is less than 3 and x is greater than 1. You can actually adapt it a little bit more by saying, okay, -1 less than x, because all I did was flip that, and x is less than 3. And you're going to learn that. So this is how I would write this inequality in set notation for an and. When it's an and, you're only going to have one x value. -1 is less than x. Or another way to say that is x is greater than -1. Well, that's true. But x also has to be less than 3. That's true. So that's the only parameters that that answer can be. Okay. So let's try this one. This is an or. And this is going to change it a little bit. So the or matters a little bit differently because you're going to have two separate sets of work. Using a colored pencil, -4, less than. Okay? Different color. 0, greater than. Using a third colored pencil, darken the section of the number line where x is less than -4 or x is greater than 0. Well, it's those specific sections. So you would have to leave this as x is less than -4 or x is greater than 0. You're really not going to do anything else. You have to actually have the word or in there. That's important. Okay, so how do we actually graph these on inequalities when we're given words? Well, that's what this lesson's about. Graph the compound sentence. Compound meaning there's more than one thing happening. So, x is greater than -2. I graph one thing first, and then I fill in the second part. Or x equals -2. Well, if x equals -2, that means now I have to fill this in. Those are all of my solutions for that. So x can be -2 or anything greater. Well, what about this? How could we abbreviate x is greater than or equal to, or x is greater than -2, or x is equal to -2? So how would we abbreviate that? Well, we would abbreviate that as x is greater than or equal to -2. Okay, rewrite x is less than or equal to 4 as a compound sentence. X is less than 4 or x equals 4. And then we would graph it. I'm not going to spend my time doing that, but that's what we're doing here. We're trying to make two different statements. Moving on. Aha. Okay. So, ors. We're going to have two really different things. X equals 2 or x is greater than 6. Open circle, going this way. That's this one. -5, less than or equal to. Greater than or equal to. But this is the guy that I want you to take a look at. I want you to try this one on your own. See if you can graph this correctly. So it says rewrite as a compound sentence. This really is a compound sentence. But rewrite it anyway, and then graph it. Go ahead and pause me. Okay. So you've unpaused me. We're going to break this down twice. This portion right here. That's one of my inequalities. So when I look at this and it's one statement, I put the variable on the left and I flip the whole thing. X is greater than or equal to 1. But because it's one statement, we know that it's an and. Then I'm going to break it down into a different color. So now I'm going to erase this. And I've got this portion of it. X is less than or equal to 3. That's my statement. So how do I graph this? Well, I'm going to start, because it's less than or greater than or equal to, I'm going to put something at the 1 and I'm going to put something at the 3. Why? Because it's equal to those numbers. Well, if it's greater than -1, it goes this way. If it's less than 3, it goes this way. So what's the area that I only want shaded? Well, I only want shaded in between those. Why? Because those are the only things that work for that particular compound and sentence. Okay, so I have no idea where the video stops, so I might be repeating myself. but I'm guessing that you've seen this part, okay? This is what I've shaded. But if that doesn't make sense, if you need to say, okay, here's 1, and I'm going greater than, great. Here's 3, and I'm going less than, great. Well, where do they overlap? Because that's the only answer. So where they overlap is right here. So that's all that should be shaded. So if I ask for an answer, I don't want to see all this multiple color. I don't want to see this blue. I don't want to see the red. I only want to see what the correct answer is. Don't make me have to guess, because if your shading looks off, I'm not going to know. That's your answer for these inequalities. Let's try another one. You know. Determine if it says this is true or false. No. I don't like or questions. I still don't like or questions. Aha. But let's talk about this. Immediately, you should know something, or you will eventually, about these two types of graphs. Right now, we have an overlapping graph. If it's overlapping like this, we know that this is an and question. If it's here, so really when I learned this, it was hysterical. Because our teacher said it's either in between or it's Egyptian arms. In between means and, Egyptian means arms. In between and, Egyptian arms mean or. And I'll never forget that. And I took this, I took algebra in 7th grade, I think. 6th grade, something like that. And I'll never forget him. His name was Mr. Kelly. So I know this is an and, which means my x is going to be in the middle. But if I don't know that yet, I know that x is going to be greater than or equal to -3. Why? Because it's graphing this way. Well, now we start at this point. I know that x is less than or equal to 4. Why is it less than or equal to? Because it's a closed circle and it's going this way. Well, how can I put this? Well, -3 is smaller, 4 is bigger. Now I need to figure out how to write it. Well, it's pointing at the -3, so it stays pointing at the -3. It's pointing at the x, so it stays pointing at the x. And there's my compound statement. When it's an and, the in-between, you're only going to have the x once. The or, the Egyptian arms, okay, like walk like an Egyptian? Okay, good. I just did that on camera, I know. This is going to be an or. So x is less than -4. Why just less than? Because it's an open circle. Or x is greater than 0. You can't simplify that anymore. This is difficult, which is why lesson 15 and lesson 16 are going together, and we're going to do a bunch of this in class. I'm fine to slow this down once we get into class and do some practice problems. And I think that takes us to the end of the lesson, and I love it. And is true if both solutions work. So and is true if both clauses are true, and they say clauses. Both solutions are true, or is true if only one of them is true. Could they both be true? Sure, but only one has to be true. This takes us through lesson 15 and 16. Have a great day.